Hi and welcome back. Today we're going to look at section 4.6, which is Newton's method. Hopefully you watched the intro video. There's really not a whole lot in this section. You just have to know this formula that's given to you. Just want to talk to you real quick, make sure you're okay with what it's telling you to do, and then we're going to look at maybe a couple of quicker ways to fill in these charts. For you guys when you work these problems out and try to get these estimated answers. All right, so just remember Newton's method, this formula that we're going to be using, is just a method that Newton figured out that finds approximations and very close approximations to zeros of an equation. So just remember that in order to know the equation that you're going to be working with, it has to be set equal to 0, because then you can replace the 0 with the f of x. Okay, and then truly the trick of this whole thing is that you pick a good initial guess. Okay, so to make it easier for all the calculus teachers and for your tests, typically we give you the guess. Okay, we will give you the starting value. So for example, on the video on example 1, they told you to start with your initial guess as 2. So typically you're going to see your initial value either x sub 0, sometimes they'll even give you the initial value as x sub 1. So that's really not important, okay? What's important is that you just keep up with the subscripts until you get to the one that you're looking for. So in the video they started you with x sub 0, and that's usually what we try to do. And so for me that would be that initial guess that you're working with, okay? And like I said, the trick is that you want to have a good initial guess. So basically, when you look at a function and you're trying to find the root, and you're going to do this basically without the help of your calculator, Newton's method is what we would use. So when I look at a graph, so this is just an example of what this is telling you to do. This is taking the function value, okay, of plugging that value into the function and into the derivative, and then dividing that and subtracting that number from your original guess. So typically your original guess is going to be a whole number, okay? I mean, you're going to be getting roots that are decimal answers. So you don't want to pick a guess that's a decimal. So we would pick something close to this that most likely was a whole number, okay? So let's just say this is where the whole number is, okay? So we would go to the function value, which would be here, okay? So that would be this y value up here. And then we'd also look at the derivative. Well, the derivative at this point would be the line goes like that, right? Tangent line. And we would take the value of the derivative of that point, plug it in this formula, and what it's going to give me is the next approximation, the next guess. Okay, the next x. So right here where it crossed x, that would be our next guess. So we would call that x sub 1. Okay, then we'd start all over again. So now this is my guess that I'm looking at. Find the function value, which is here. Find the tangent line, which is here. Okay, plug those numbers into here. And that would end up giving us another approximation, call that x sub 2. And we would keep doing that and keep doing that. And basically what's happening is we are zeroing in to figuring out what that exact value is. So it's kind of cool how it works, okay? But the thing is that you need a good initial guess. So again, you either have to come up with a good guess based on the graph, or typically you will be given the starting value, okay? So let me explain if you didn't have a good guess, okay? What happens if you guessed here for your starting? Okay, I'm going to put bad guess over here. Okay. If you pick something not a good guess or on the wrong side or too far away, and you find that x value, and you do the tangent of that, look at where it's going to be. It's going to be farther away from that value, okay? Then you would pick that point, find that tangent line, wherever it may be, And you're going to get stuck in this vicious cycle that's not going to get you close enough to the actual root. So it is important that the initial value that you start with is going to work. You know, the same thing, what if a function had two roots? And you needed to find the specific root, you need to be closer to that root, okay? So just keep in mind that typically we're going to give you the values, but if not, you know, if you're not given a starting point, then you need to pick a good value. And remember, what does it mean to find a zero? That means when you plug that number into the function, you want to get as close to zero as you can. So if you have to make the guess, then you would plug in a number here, like let's say 1, and work it out, and do get close to 0. If you plug 2 in here, you're going to get close to 0. So that's why they started you with 2. So you can pick your own number, okay? But just go with what they give you if they start you with something. All right, so the other thing I wanted to mention to you is that we give you guys this chart because it's kind of nice that you can follow it and do the formula. And so a lot of times for me, instead of writing these over and over again, I just call this column A, B, C, and I know that my formula, my Newton's method, is to take the first column minus the second column divided by the third column. And that's what this formula says to do. That's the first column, your guess, and then the function value divided by the derivatives value at that point, okay? So typically on a test or on the final exam, you're not going to be given this. You know, you're just going to be given this statement, and that's it. So you just need to know, you know, you can either set up your own table or just know how to work that, but you're not going to be given this table typically on a test or on the final exam, okay? All right, so Dr. Taylor did 2 of these with you, which should be plenty to know the formula, but we got 2 other things to do on the notes. So we're going to go through another problem, and I'm going to show you some tricks on the calculator to help you solve that, okay? All right, so number 1 was done for you. Number 2 was done for you. So we are going to go to number 3, okay? All right, now we're going to start this as we did with all the problems and kind of go through it by hand just to make sure you're okay. And I'm going to show you again some little tricks on the calculator to help you get these values, okay? All right, so first off, here's our initial value, x sub 0. So we're going to start with 1, okay? And then I need to make sure that my function is set equal to 0. So I have the inverse tangent of x equals 1 minus x. So I've set that equal to 0. I am going to move the x over and the 1 over, so the x will become positive. I'm going to put that first, and then the minus 1. Okay? All right. So now that's my function value. So I'm going to put the function value over here. F of x equals the inverse tangent of x plus x minus 1. Okay? And then we need the derivative. Okay, so what is the derivative of the inverse tangent of x? Remember that is 1 over 1 plus the argument squared, and then times the derivative of the argument, but it's just 1, so we don't need that. Plus the derivative of x is 1, and then the derivative of negative 1 is 0. So here's my derivative, and there's my function. All right, so we need to find f of 1. Right, that's our starting point, our guess. This is our first guess, and that was given to us, what we're going to start with. So we need to find f of 1 and f prime of 1, right? So that's what we're doing here, taking this number, this guess, plugging it into the derivative and to the function, okay? All right, make sure your calculators are in radian mode, okay? Double check that before we begin. All right, so we're going to do the inverse tangent, second tangent, okay, and our x value is 1. I'm plugging this in here, plus 1 minus 1, which is just going to cancel itself out. Okay. So that gives us our function value at 1, 0.7853981634. So I'm going to go ahead and do this as well. Okay, so I'm going to do 1 divided by, and you could do this in your head, but I'm just putting it in here, parentheses, 1 plus 1 squared, close parentheses, plus 1. At 1.5. All right, so I'm going to put those numbers in my chart. So we have 0.7853981634 and 1.5. Okay. All right, now to get this number, we're going to take this minus this divided by this. Okay. All right, so one of the things we're going to do on this calculator is use, our copy and paste. So we need our initial value, 1 minus, and then here's the function value, and there's the derivative. So I'm just going to arrow up to that, divided by the derivative, and hit enter. So there's my new approximation, 0.46401224. Okay. All right. So this is the new approximation. So we're going to call that x sub 1. So we started with our guess of 1, and now our new guess is this 0.47. So remember my picture up here. We're moving around, so sometimes we jump back and forth over that root, but we're trying to get closer and closer to the root. Okay? All right, so now this becomes x sub 1. This was x sub 0. So this is 0.4764 012244. All right, so now I have to find f of this. So I've got to put this into here, right? And then I'm going to find f prime of this number, which goes into here. So I can type it in, just like Dr. Taylor showed you on the intro video. Just like we did here, we can plug those numbers in. I'm going to show you just a little trick on the calculator so that we don't have to keep typing that stuff in over and over again. Okay? All right. So I'm going to start at the beginning, just so you can kind of see what we did, and then we'll do this one. So let's say I want to start back up here. All right, so the first thing I want to do is store my x value. Okay, so I'm going to hit 1. That's going to be my first guess. So I'm going to start this problem over, and I'm going to hit enter. You always have to hit enter, and then you're going to hit the store button, which is down here to the left of 1, STO. Okay, go ahead and hit store, and then you have to tell it where you want to store it. So we're going to use x. Always x to store on this calculator. So we're going to hit x and then hit enter. So now your calculator knows that anytime you have x in a problem, it's going to plug in 1 to that. So now I'm going to type in my function first and then the derivative. Okay, so second hand x, close my parentheses, plus x minus 1. Okay. Now, when I hit enter, it's going to plug in 1 into these and give me the answer. So if I hit enter, notice what I get. 0.785, I get the function value. Okay. Now, I'm going to plug in my derivative. 1 divided by, make sure you put this in parentheses, 1 plus x squared. Close your parentheses, and then plus 1. Now I'm going to hit enter for that. Now remember, as far as the calculator is concerned, x is still 1. So I'm going to hit enter, and notice I get 1.5. Okay? And so now I have my 3 values right here. So I could do 1 minus the function value, go up there, hit enter, divided by the derivative, enter. All right, so there gives me my number, right? Okay, so now, this is now my new x, right? I'm changing from 1 to this value. So now, this is what I want to store. So this is where you have to remember to store. So put a little thing here and write, don't forget to store it if you're going to use this method. So I'm going to hit store again. I'm going to hit X again. And now I'm going to hit enter. So now my X is this. Okay? Now, even nicer, I don't have to keep typing these in because they're in there. Okay? They are already up in there. So remember, to get what you typed in, you can do second entry, and we want the function. So let me remind you, second entry, that'll give you what you entered, and you can keep hitting that until you get what you want. So I go up a couple of lines. So I'm going to hit second enter. That's not what I want. Hit it again, second enter, not what I want, second enter. That's the derivative, not what I want, second enter. There's the function. Okay, now you can type it in again, it's no big deal, but it saves you time once you start knowing how to use the buttons. So now I'm going to find the function value using this as my x. I'm going to hit enter. Okay, so now that is the first function value using this. Okay, so I'm going to put it up here and write it down. All right, so I got negative 0.07900778869. Okay. All right, now what do I want to do? Now I want to do second enter until I get the derivative here. Second enter, second enter, second enter, second enter. All right, so there's the derivative, and now it's going to compute the derivative with this number in it. Okay, I'll write that down, 1.815. 0.23739. Okay. All right. Now, what do I do here? I need those three numbers. I need to do the original number on this line, which is that, minus this divided by this. So I'm going to go up to that, minus that, divided by that. Enter. All right, so there's my new approximation. 0.5199311162. All right, so that's my next approximation, x2. Okay, so that's what I want over here. So I'm zooming in on my real answer, the root 993111162. Okay, so what do we do? This is my new approximation. Store it. Okay, that's got to be the new x. This is our third line. This is the new x. So we're going to hit store, x, enter. So now this is the new x. And I want to put this into here, into here. Okay, so second entry until you get the function. Okay, enter. And then second enter until you get the derivative. All right, so now here are my three numbers. Now let's talk about this. Remember, exponential or scientific notation, e to the negative 4 means you're going to move that decimal place 4 places back to the left. So that means you're going to add 3 zeros. Okay, so that number, slide that over, will be negative 0.0006 0381 5543. Okay, you can write it in scientific notation. That's the way you write it. And then here's our derivative function value, 1.787198. Okay. Now, remember, when you're doing function and function values, this number right here, okay, your guess needs to be getting close to 0. Okay? No, this needs to be approaching your solution. And this is approaching the solution. your function value, the y, remember this is your actual y value, needs to be approaching 0, right? If you're not approaching 0 here, something is wrong, because this function value, our guesses are supposed to be getting closer and closer and closer. Because remember, this is the root, this is the y coordinate, and any root, the y coordinate is 0, right? So this should be approaching 0. This should be approaching the actual value of the root. And typically, for Newton's method, what we want to do, and when computers are running this program, is it's going to keep finding it. It's going to go through lots and lots of repetitions of this until all of these numbers start repeating. So in other words, it's so close to the root that the differences are so far out in the place value that it's going to say, okay, that's good enough. Okay, because obviously the roots are irrational numbers. So that's what we try to do, is see some kind of repetition in these digits. So on this one, we're not quite there yet, but that's what would happen. All right, so let's find our last guess. So we need the starting number, right, minus this divided by this. So it's nice because they're all on the screen and you can see them. So we're going to start with that minus function value divided by the derivative. Okay, we got the first number repeated, but that's it. 52026897722. So there's our x of 3. Okay. All right, but all they asked us to do is to go to that 0.52026897722. All right, so hopefully that'll help a little bit to kind of get this done faster instead of doing it all by hand. So you can use that store function on your calculator to help you with that. Okay. All right. Now, if you want to know the actual root, you could graph this, see where it crosses the x-axis, find the 0, and see how close you are. Because remember, this is just the third approximation. So it's not going to be exact, but it should be pretty darn close. Okay? All right. Last question, got 2 parts, 4a and 4b. So here's another way that you can use this formula to kind of help you with solving these problems. So this says find the equation f of x that results in a solution of the 4th root of 9. Okay? Well, if that's a solution, remember, that's a 0. And zeros are the x values. So let's start with that. Okay? All right. So for me to find a function value, a couple of things. Okay? I can have no roots, and then I have to have it set equal to 0. Okay? So the first thing I want to do is get rid of the root, the 4th root. So how do you get rid of the 4th root? I'm going to rewrite that. So just like a square root, if it was a square root, you would square both sides. So if it is a 4th root, you would raise both sides to the 4th power, right? So on the left, I now have x to the 4th. And on this side, the 4th root will end done raising something to the 4th power. So I'm just left with 9. And then I got to set this equal to 0. So x to the 4th minus 9 equals 0. So there is your function, f of x equals x to the 4th minus 9. Okay? All right, so think about it. If you solve this backwards, you would add 9 to both sides, you'd get that. You would take the 4th root of both sides, which would be that. That's the solution, okay? So we're just kind of taking a problem and finding the equation that was the root. You can always do that, okay? Just like, you know, if x equals 3, that's why the factor is x minus 3 equals 0, right? We're setting them equal. So it's the same thing over here that's happening. All right, so if that's your function value, then your derivative is 4x cubed, because in the next part, we're going to find an approximation. So here's your answer for part A. Find the equation. All right, so part B says find the second, third, and fourth approximations of the roots to this function if we guess, our initial guess is 2. Okay, so our initial guess is 2. So that means we have to find f of 2, and we have to find f prime of 2. Now I don't keep writing this down because obviously the decimals get kind of long, so it's hard to do all that. But that's what we're doing. Whatever number's here, remember you're finding f of that number and f prime of that number. So I just always start off with this. All right, so what is f of 2? Okay, so we can do that kind of in our head. 2 to the 4th is 16 minus 9, so that gives us 7. And then f prime of 2, 2 to the 3rd is 8, and 8 times 4 is 32. So over here you have 2 minus 7 over 32. Okay, so let's go ahead and get our calculator going with the derivative and the function value so we can find the rest of those. All right, so I'm going to start this over. So I want to store 2, hit 2, enter, stored in x. All right, put your function in, so x to the 4th minus 9, enter, we should get 7. Put your derivative in, 4x to the 3rd. We should get 32. Okay. Now, let's go ahead and divide that out. So we're going to do 2 minus 7 divided by the derivative. All right, so that one's not too bad. 1.78125. So that's our next approximation, x sub 1. So now we're not going to use 2, we're going to use 1.78125. So this is what has to get stored now. So we're going to hit store, x, enter. So you should see that number again. All right, now second entry until we get to the function. Second enter, second enter, second enter, second enter. Okay. So we're going to put 1.78125 into here. And then second entry until you get to the derivative. Second enter. All right, so I'm going to write those two numbers down in my chart. So the function value is 1.066987038, and the derivative value is 22.60656738. And now we're going to divide those out, do the formula. Okay, so remember this minus this divided by that. So go up and grab your numbers. That minus that divided by that. All right, so there's our new guess, 1.7340519, and that is now our x sub 2, our new guess. Okay, so x sub 2, 1.7340519. Now notice here we're starting to see some repetition. So hopefully by the next guess, we'll see 1.78 at least. Okay, so now we know we're zeroing in on the value. All right, so we got to store this. So store that in x. Get your function value. Second enter until you get your function value. And then second enter until you see the derivative. Okay. All right, so there's our next two numbers. So our function value is 0.04166405. Derivative is 20.856732226. And then we need our next guess, so we're going to do the formula. Okay. So this minus this divided by this. So 1 minus function value divided by derivative. Okay. 1.732 2054269. All right, so we only still got 1.73. Oh, well, that repeated. Okay, so we're getting there. 1.73, 205, 4269. All right, so remember, this should be getting closer, so our digits should start repeating. This should be getting closer to 0. All right, so we gotta go one more time. So we need to store this number. So store x. Okay, and now we're ready to get the function back. So second enter. And then the derivative. Okay, remember that means move the decimal 5 places back. So it's going to have 4 zeros in front of that. So this will be 0.0000719496159, and the derivative 20.7847331. All right, so there's our two values. And one last guess. This is what I'm going to end on. So we need our guess minus function value divided by derivative. Okay, this time we get 1.732050807, and that's our fourth approximation. Okay, and if you look at the third, look how many numbers we're repeating now. We have 73205. So this means this is your approximation 1, 2, 3, 4, 5 places, right? 5 places past the decimal. So sometimes they'll ask you, find the approximation up to 6 digits. Well, that means the first 6 digits have to be the same, okay? So the more digits you see the same for each of these approximations, that means this is super, super close to the actual value, okay? At least 6 places out it is, okay? All right, so hopefully learning that calculator will kind of take a little bit of time off of it. And remember, typically you'll be given that starting value, but if not, then you got to come up with a whole number function value. When you plug it into the function, that will give you something close to 0, okay? So think about why we started with 2 here. 2 to the 4th minus 9 was only 7, okay? But if I started with 1, the next closest whole number would be 1. 1 to the 4th is 1. 1 minus 9 is -8. -8 is farther away from 0 than 7 is. And if you go to 3, well, 3 to the 4th minus 9 is hugely far away from 0, right? So we want to be close, so that's why they chose the number 2. That's the closest whole number that fits in the function closest to 0. So if you're not given that, don't email me and say, because I think there's one on WebWorks where you're not given that initial value. So you just plug in some numbers until you figure out what X value will get you close to 0, okay? All right, so hopefully that helps. Work on your WebWorks. Let me know if you have any questions. Okay.